Hi, this session is on some area questions, and we'll be finding the area of triangles and some quadrilaterals, and we'll include some composite shapes. Our first question says, find the area of a rectangle with dimensions 300 meters by 40 meters. So you have a go first, and please draw a diagram as well. Okay, so we know a rectangle has a length and width, and the dimensions were 300 by 400 meters. Okay, so length is longer in a rectangle, so we'll put 300 here. So 300 meters by, it was 40 meters, sorry. Okay, now when we're finding the area of a rectangle, we know the formula is equal to length times width. So always state your formula. So area is equal to, length is 300 meters times 40. Now I don't need a calculator for this. 3 times 4 is just 12, and I know I add on my zeros. There are 3 zeros, 1, 2, 3, so add them on. Now don't forget to write our units. We're working in meters, and we have just found the area, so make sure we put squared. Okay, that represents the area in squares. So this area, if I put a comma there, is 12,000 square meters, or I can say 12,000 meters squared. Okay, for our second question, it asks us to name the first 8 polygons. Okay, so just to recap what a polygon is, so just in case you have missed out on a lesson that involved polygons, please write this down. Polygons are two-dimensional shapes, so 2D shapes, so not popping out, with straight sides that are all joined to form a shape. So if I look at these examples down here, the first one is a polygon because it has straight sides, all the sides are straight, and all the sides are joined, okay? And it's a 2D shape. The second one is not a polygon because I can see this side here is curved. So I would say that it's not a polygon. And the last one is also not a polygon because over here I can see 2 sides or 2 points that aren't joined. So all the sides must be joined. So that's what a polygon is, a shape with straight sides and all joined. So we name polygons depending on how many sides there are. And also another fact to remember, the number of corners equals the number of sides. So if I have a look at this polygon here, if I count all the sides, 1, 2, 3, 4, 5, there are also 5 corners or points. 1, 2, 3, 4, 5. That's another trick to remember. So to name polygons, we name them according to how many sides they are. This one here had 5 sides, 1, 2, 3, 4, 5. So it's actually a pentagon. A pentagon is a polygon with 5 sides. I would say this one's an irregular pentagon because all the sides are different lengths, but it's still a pentagon. So now see if you can write down the first 8. I'll give you a hint. The smallest polygon we can have in terms of number of sides is a triangle. And then see if you can write down some more. Okay, so I've just got this table here. So triangle is the smallest polygon. I have to have at least 3 sides to draw a shape. So you should have triangle. Quadrilateral, we know quad means 4, like quadruplets. So quadrilateral are any polygons with 4 sides. And here is an example of a square. Okay, then pentagon is a shape with 5 sides. That one there is a regular pentagon. All the sides are equal in length. Hexagon is next. So that's got 6 sides. A heptagon, or you can say septagon, has 7 sides. And an octagon has 8 sides. So how many do we have? We've got 1, 2, 3, 4, 5, 6. If I go 2 more to get 8. So this one here, nonagon, has 9 sides. And decagon has 10 sides. So they are the first 8 polygons. So starting with a triangle all the way down to a decagon. And a decagon has 10 sides. Okay, name each of these quadrilaterals. So as we just saw before, a quadrilateral is a polygon that has 4 sides. And we saw an example of a square, but there are other types of quadrilaterals we can draw. And see if you can name all of these. It's important to be able to identify which is which and name them all. So have a go first. Okay, so let's start off with shapes that we have already seen. The square, and add these features in. I know a square has 4 equal sides and all the corners are 90 degrees. So all the corners are equal. And that's what I call a square. I can fit it in here. The next shape that we've dealt with is a rectangle, similar to a square, but instead of all equal sides, the opposite sides are equal. So the two lengths are equal. So I've got 2 dashes there, and the width and width are equal. So 1 dash each. So we know the amount of dashes tell us if they're equal or not. And all the sides are 90 degrees as well. Sorry, all the corners, all the angles inside, interior angles are 90 degrees. And that is what a rectangle is. So this one's a rectangle. Okay, if I move on to, I'll go to this one here. It's actually called a parallelogram. And if you compare it to a rectangle, it's pretty much the same shape, except the rectangle has been squished. That means if it's just a rectangle that's just been squashed, that means these two sides are also equal in length. But with parallelograms, you'll see instead of 2 lines, you'll notice sometimes there's 2 arrows, just like that. So they're still equal in length, but they're telling you these 2 lines are parallel to sort of remind you it's actually a parallelogram. So I'll use arrows for the sides instead of lines. So I'll rub those off. So parallelogram, yep, all the opposite sides are equal in length. They're usually shown by arrows, and opposite angles are equal in length. So that angle and that angle would be equal, and this angle and its opposite over here, they're also equal angles. Okay, so there's some features of a parallelogram. My next one here, you can sort of see it looks like a square, but it's been squished. So this is called a rhombus, and we'll just spell parallelogram. So parallelogram, you got P-A-R-A, para, and then double L-E-L. So just remember double L-E-L, parallelogram. All right, so then this one here we said was a rhombus. A rhombus is spelled R-H-O-M-B-U-S. Okay, rhombus. And because it's a squished square, all the sides are still equal. But the angles are no longer 90 degrees because it's been squashed. But once again, opposite angles are equal, just like a parallelogram. So that angle and that angle would be the same number, and this one here and this one here would be the same number. Okay, so that's just the difference between a square and a rhombus. The angles have changed. Now, before I continue, if you're wondering why these 4 that we've just looked at are green, all the same color, it's because they are all types of parallelograms. So what I mean is all the opposite sides are parallel. So this line here and that line there, they're still parallel, they'll never meet, and the same with the width. The square, the sides are still parallel, all the sides are parallel, just like a parallelogram, and the same with a rhombus. Okay, but we call a parallelogram this one here, that's its actual name. So that's what we call it, but just keep in mind that technically these other 3 are also types of parallelograms. Okay, I know it's a bit confusing, but just remember they have the same properties as a parallelogram in that the opposite sides are parallel. Now the last 2, now we can see why these are not any type of parallelogram. If I have a look at this one here, this is called a kite. And I can see, for example, this line here and that line there, they're already meeting, they're touching. And just to recap, parallel lines are lines that never meet. Okay, they go on and on forever, and they will never ever meet. Okay, whereas here, they're already touching at a point. That's why a kite is not a parallelogram. Now, some features of a kite. Well, this length and that length are equal. So the 2 adjacent sides, adjacent means side by side, they're equal in length, and then these 2 are also equal in length. Okay, so side by side. And this angle here and that angle there, they are equal in length. Equal in size. So the angles are equal. This angle here and that angle down there are not equal, just those 2. So that's a kite. And the last one, a trapezium. So trapezium. Now trapezium can actually look different to this. For example, if I drew a trapezium just here, just like that, that is also a trapezium. So it looks quite different. And the main way to know if it's a trapezium or not is two things. You have to have one pair of parallel lines. So this line here and that line there are parallel. So I'll put arrows there. And this one here and that one there, they're parallel. They'll never meet. But then the other two sides are not parallel. So if I was to extend this line and that line, eventually, if I just extend it, so I can't do it with this, they will eventually meet. Okay, so if that line was extended, it's not working, but they'll eventually meet. So that's how we know it's a trapezium. A trapezium only has one pair of parallel lines, and then the other two are not. Whereas a kite, there are no lines that are parallel. They all meet at a point. Now this one here, yep, I can see I've got two parallel lines, and this one are not. So if I kept drawing these lines, they would eventually meet and cross over. See? They'll eventually meet and cross over. So trapezium usually is shown with two arrows showing that line and that line's parallel, and that's it. So all the angles can be different, all the side lengths can be different. In this trapezium here, we can see this side length and that side length are equal in length. But in this one, nothing's equal in length. Okay? But they all have a pair of parallel lines. So please make sure you can spell these shapes and can also identify them. Okay, for our next question, question 4, locating the height of triangles. So state the base and height of the following triangles. So they're not asking you to work out the area. All they're asking you is what is B and what is H. So state means you have to actually say B equals and H equals. So have a go first. And just in case you've forgotten this or didn't learn it, the tip is outline a T or a L to show the base and height. Because we know with triangles, the base and height must be perpendicular. Now, if you have missed out on a lesson and don't know what perpendicular means, please write this down. Perpendicular lines touch at 90 degrees. And so they make a right angle. So a right angle is 90 degrees where we see like an L or a cross or a T shape. And it's shown by that square there, that little square. If you ever see it in a corner, it means that the angle between these two lines, the space between them, is 90 degrees. So just make sure you write this down if you haven't got it already. Okay, so I'm going to highlight the base and height to show you what I mean by the L shape or the T shape. So if I have a look at my first triangle, I am going to highlight that T shape. So the base has to be part of the triangle. That's another thing to remember in case you've forgotten. The base is always part of the triangle. So first I'm going to locate the base for all of these. So here I've got 10 centimeters from there to there. It's the only length given from the actual triangle, one of the side lengths. So that has to be a base. Okay. Over here I've got 7 centimeters. That 7 centimeters is not part of the triangle. So it can't be the base. The base must be 15, part of the triangle. The base here, well, I've got 4 centimeters. That dotted line is not part of the triangle, so my base must be 9. And over here, now there's a lot more information in this one. I've got 9.3, 11.1, 11.6. So first of all, which ones are, and 4 meters. So which one's actually part of the triangle? Well, 4 meters, 11.6 meters, and 9.3 meters, they are all part of the triangle. So any of these can be the base. So based on the information that I have, what line is perpendicular to the base? So that 4 meters is not perpendicular to 9.3. So I can see this 3.6 is making, it's just showing me a corner there. So that has to be my height. So the base must be 9.3. There's my base. And I can see the height, if I just change my color, the height is perpendicular to the base. And there's my L shape. Here, there's my base, there's the height, 4 centimeters, and I'm making that T shape. Here it's 15 centimeters, my base, and the height is 7 centimeters. Okay, and it's perpendicular to the base. And there's an L shape. And last one, I've got my base there, and there is 4.5 centimeters. And if I draw that line straight, I'll use the highlighter, I can see I've formed a T shape. Okay. So I've got T shapes and L shapes. That's how I know for sure they are perpendicular. Okay, so this one here, base would be 10 centimeters, height is 4.5 centimeters. Here, base is 15 centimeters, height is equal to 7 centimeters. This one here, base is 9 centimeters, height is 4. And the last one, all I needed was 9.3 is my base, 9.3 meters, and my height is equal to 3.6 meters. So it's really important to be able to identify your base and height of a triangle, because we need that to work out the area later on. Okay, so our next question asks us to find the area of the following triangles. So please have a go first and draw these into your books as well. Okay, so for our first one, we need to identify the base and height of a triangle. But first step, let's write the formula of a triangle, the area of a triangle. We're trying to find the area. So area is equal to base times height, and I divide that by 2, I halve it. If you wrote your formula like this, area is equal to half of the base times the height, or BH, that's fine as well. We know they are the same thing. Both of them are halving it. Okay, so what is my base and what is my height? So if I have a look at the 3 numbers, I don't need to use all of them. Any of these can be my base, but which side has a perpendicular line? I can see that the 4 centimeters and that little corner there, that 90 degrees is giving me a hint. That 4 centimeters and that 7 centimeters, they are perpendicular. They form 90 degrees, they make my L shape, so that is my base and height. I don't need the 8. So area is equal to, instead of B, I'm going to put 4. If you want to, you can say B is 4 centimeters and height is 7, if you want to see it nice and clearly. So I'll substitute B for 4 here. So 4 times 7, and I divide that by 2. Okay, so we do the top part first. So 4 times 7 is equal to 28, and I divide that by 2, and half of 28, or 28 divided by 2, is 14. And our units are centimeters and squared. Okay, now if you just put that all into your calculator, 4 times 7 divided by 2, you would still get 14, which is correct. But just remember that it's important to get into the habit of doing the numerator first, because if that was a plus, we would have to make sure we put brackets there, and we'll learn more about that later on. Okay, for our next question, please make sure you've had a go first. We can see we've got a triangle, so once again we're using the same formula. So I'll just write that down. Area of a triangle is base times height, and divide that by 2. Or the times can be invisible, or you can write it as well. Okay, so sometimes when triangles are rotated differently, it can look confusing. If it helps, imagine you had this on paper, you can rotate it to whatever angle you want. Okay, and here I can see my base is going to be 7, perpendicular to the height, which is 4 centimeters. And that 90 degree symbol is giving me a good hint. Okay, so if that helps, make sure you rotate it when you've got it on paper. So I'm going to just draw my L shape. There's my base, and there's the height, perpendicular, and they're showing me 90 degrees as well. So I don't need the 8 and I don't need the 5. I just need 7 and 4. If I was doing the perimeter, yes, I'll add up all the sides, but we are doing area. So area is equal to, my base is 7, base is part of the triangle, and height is 4, divide that by 2. And I'll just do the top part first. So once again, we have the same, I think we'll have the same answer as the previous one. So 7 times 4 is 28, and I divide that by 2, and we get 14 centimeters squared. So it happened to be the same area, but it was a different triangle, and I guess this one was a bit trickier. Okay, for our next one, it says to find the area of the following. So have a go first, and you should be able to identify what shapes these are. Okay, so for our first one, we've got a shape that has opposite sides that are equal, and we can also see these arrows telling us that they're parallel. So if both sides are parallel and it looks like a squished rectangle, it's a parallelogram. So the formula for the area of a parallelogram, area is equal to base times height. Okay, so it's basically the same as a rectangle. A rectangle is area is equal to length times width, but instead of length we have b, instead of width we have h. And if just in case you missed out why that's the case, if I cut this part of my parallelogram out, there's my triangle I've cut out, it will fit exactly over there. So if it fits there, I am left with, so I cut that part out, I am left with a rectangle. So the area of a parallelogram is exactly the same as the area of a rectangle. That's why the formula is pretty much the same as a rectangle. Okay, so now base and height, just like a triangle, have to be perpendicular, and the base has to be part of the parallelogram. So I can see 4 millimeters is part of the parallelogram, so that is my base. And the height, there's my 90 degrees, so that line there is perpendicular. It goes from one line to the other line. That's the height. And 4 times 3, and we divide that by, oh sorry, we're not dividing, it's not a triangle, so we just go 4 times 3. So area is equal to 12 millimeters squared. That's why it's very important to write your formula first, just to double check that you got the right formula for the right shape. Okay, our next question, question 7, well, it has composite shapes. So composite just means combining two things. Okay, so combining shapes. So composite shapes are formed by combining shapes or removing a shape from another. Okay, so we can in this case we can see the rectangle and the square are being put together, but sometimes I might be able to cut out a part of my shape and create a composite shape. So we'll have a look at an example later. So find the area of the shape that was once a rectangle and a square as shown below. So have a go first. So I've just put my composite shape here. We saw before it was a rectangle and a square combined, but just say you didn't have the other image. All you got to do is do like a dotted line or even a line to show, yep, there's a rectangle and a square that have been combined. Because most questions you're not shown them separated, you're just given the one composite shape like this. Okay, so all we got to do is to find the area of the rectangle, find the area of the square, and add them together. So let's find the area of the rectangle. So because I'm working with two different shapes, I'm going to write a little heading, area of rectangle, just so my working out is nice and clear. So area rectangle, the formula of a rectangle, the area is equal to length times width. Okay, also if it helps, if you want to draw the shape separately, so you can see, yep, that's 2 meters and that's 3 meters. So my length is 3, my width is 2. That you can do that as well. So area is equal to 3 times 2. Area is equal to 6 meters squared. So I found the area of my rectangle. That's done. Now what's the area of a square? So area of square, that's my little subheading, so my working out is nice and clear. Area of a square, well, if you want to draw it as well, you can draw it separately. It's 6 meters. I know a square has equal sides, so every side is 6 meters. Now the area of a square, its formula is L times L, or you can just write L squared. Either one is correct. Area is equal to 6 times 6, and we can see why it's L and L, the same number. And area is equal to 36 centimeters squared. Okay, so we have found the area of the rectangle, we have found the area of the square. So now one last step is to add them together. So what we can do is, right, I'm just going to squeeze it here. So try and have it all underneath each other, but if you haven't got room, just continue on the other side. So total area, okay, if you wrote area of composite shape, that's fine as well. So total area is equal to, so I am going to get this and add it with that, and I'm done. So 6 plus 36, so my total area is equal to 42 centimeters squared. So make sure you write your units in your final answer. If you wrote centimeters squared here and there, that's fine as well. Okay, so we have found the area of this composite shape. That's our final answer. So this whole area is 42 centimeters squared. Composite shape. Question 8, it asks us to find the area of this one here. So please have a go first. And remember, when working with composite shapes, you can draw lines or dotted lines to break up the shape. Okay, so if you got stuck on this one, that's okay. So the first thing I'm going to do is, I can clearly see there's a part of a triangle stuck to a rectangle. So at this corner, I'm just going to do a line to show that I've got a rectangle and a triangle. Now I know how to find the area of a rectangle. It's length times width. I also know how to find the area of a triangle. I know the formula. So all I got to do is work out the measurements that I need for each shape. So let's start with the rectangle. Here's my rectangle. So if I just highlight it, there's a rectangle. A rectangle I need, so I'm going to write area of a rectangle. That's what I'm finding first. Area of a rectangle is equal to length times width. Now, do I have a length? Now be careful, that 12 goes all the way across here. It's not, the length is too long. The length of this rectangle that I've highlighted is 7. So I have area is equal to 7 times width is 4. So area is equal to 28 centimeters squared. So I have just found the area of this part here, this rectangle. I can highlight it, color it in. That's what I've found. Now all I've got to do now is to find the area of that triangle. So I'm going to get it ready. Area of triangle. Area is equal to base times height divided by 2, or half base times height. Okay, that is the area of a triangle. So I need a base and a height. So if I have a look at the information that I have, I can see this triangle here. This line here could be my height. It goes from a base, if that's my base, all the way to the top. What is the length of this line? It would be 4 centimeters. That length and that length are the same. They go from here to there. So that point to that point. So it's the width of the rectangle. So 4 centimeters would be my height. Now I've got to work out a base. So that height would be perpendicular to that base. There's my L shape. So if I can work out what this length is, then I've got it. Well, to work out this length, if I know from here to here is 12 centimeters, and we have done this with perimeter, finding unknown side lengths, and I know from here to here it's 7 centimeters, what do I do to work out what's left? All I have to do is subtract. So if I go 12, take away that 7 centimeters, it will leave me with this part here. Okay, so 12, if I cut off that part, so imagine 7 was here, if I got rid of that, I rubbed it off, so 7 centimeters, oh, that didn't work. If I rubbed it off, I would be left with that line there. So I can see it would be 5 centimeters. So that length, the base of my triangle, is 5 centimeters. Okay, so this one, yes, it's a bit trickier, but we have learnt all these skills to work out the area of these shapes and also this unknown side length. Now that I know what it is, the base would be 5, so let's write it in. 5 times my height is 4, and I divide that by 2. So area would be 5 times 4 is 20, divide that by 2, 20 divided by 2 is 10 centimeters squared. So I have found the area of the triangle as well, and I have found the area of this whole composite shape. So my final step is to add up the total area. So total area, or if you wrote area of composite shape, that's fine. Area would be equal to 28 plus 10. They are in the same units, so 28 plus 10 would be 38 centimeters squared. Okay, so yes, this was a trickier one, but once we realized what skills we have to use and we've learned them, it was pretty easy. Okay, our last question for this session is an application. It's got a diagram. So Bob wants to pave the area around his pool. Find the area of paving required. Okay, so just to make sure you understand, this pool here, we can see it's a rectangle. It's that white rectangle. And then around it is another rectangle, and he wants to pave this area. Okay, so the shaded area is what we're trying to find. So basically, we have a rectangle. So we have a rectangle. So imagine I had a whole rectangle, so someone's backyard, or a sheet of paper, and I've just cut out a rectangle from it. Okay, so the shape I'm left with is that shaded part. Okay, so if I was to highlight this, that's my shape, just the yellow part. So sometimes composite shapes, they're combined by, I guess in this case, it's like we've put a shape on top of another shape, like two rectangles put together. Or the other way of looking at it is a rectangle has been cut out of another rectangle. So sometimes we have to subtract. Okay, so all we're going to do is work out the area of the large rectangle, work out the area of the pool, the rectangle that we're not paving, or the rectangle that we've cut out, and subtract it from the whole area. So area of, we could say, large rectangle, if that helps, because we both have, they're both rectangles. So area of large rectangle, so we know exactly what we're doing. Okay, area is equal to length times width. State your formula. Area is equal to, the length of the large rectangle is 14 times the width is 6. So area is equal to, so if we can't do it mentally, we can just use an algorithm. 14 times 6. 6 times 4 is 24. Put the 4 down and add the 2. 6 times 1 is 6, plus 2 is 8. So I've got 84 meters squared. Our units are all in meters. So that's the area of the whole, the large rectangle. So imagine there was no pool, nothing's being cut out. But now I have to subtract what's being cut out, or what I'm not paving, according to this example. Now once again, if it helps, you can draw the actual rectangle. So I just found this rectangle, 14 meters by 6 meters. And now I'm going to find the area of that pool, the part that's been cut out or not paved. And that they are my dimensions. Okay, so area, you can put small rectangle, but I'm going to put pool, because in this example, it's the pool. But if you put small rectangle, that's fine. So area of the pool, once again, area of a rectangle is length times width. Area is equal to, the length is 4.5 times width is 2. And now all we're doing is we're doubling 4.5. When we times something by 2, we're doubling it. Or another way of saying it, what's 4.5 plus 4.5? That would be 9 meters squared. And I have found my area. Okay, and our final step is to work out the area that we're paving. So I should have put this a bit higher. So try and have it all underneath each other, or in columns. So the next thing I've got to do, area of we can say shaded area of shaded area, sorry, or we can say area we're paving. It will be equal to, area is equal to, so I get the large rectangle, so 84 meters squared. You can write it in if you want to. Take away the area of the pool that I'm not paving, or the area that I'm cutting out, and I'm left with 75 meters squared. So that's the area we need to pave. Now because it's an application, I need to write a final statement. So use some keywords. So his name's Bob. Bob wants to pave the area around his pool. Find the area of paving required. So using keywords from here. So I just wrote it up here because I haven't got room down there. So I use Bob because here's in my example. So Bob needs to pave an area of 75 meters squared. Okay, and that's it. If you wrote it differently, that's fine, but try and get keywords from the question. Thank you.